Hello and welcome to another episode of my podcast. Today I'm going to talk about morality, in particular how morality evolved and how we can use scientific models to help us understand this evolution. Now, I will share one of my papers, one of my earliest papers, in fact, that was published in a special issue / edited volume on model-based reasoning in science and technology. I believe it's a conference that takes place every 3 years. No, I think there was an interruption because of the epidemic, unfortunately. And I think they are back on track though on organizing these conferences in Europe. Anyhow, now that was one of the first conferences I intended talking a bit about the work I did for my undergrad dissertation on model-based reasoning, and in particular looking at models of morality. And I've pursued this research further in my master, in fact. Now, I was considering going into this research in my PhD, but as you might know, from where my research more went with animal consciousness, the evolution of that, I pursued a different question, perhaps equally puzzling. But yeah, let's dive right in. So if you want to model morality, what are the challenges we face here? Again, as with many problems, perhaps, morality seems a bit elusive. If you think about the evolution of morality in particular, it is hard even to define it. Where do we draw the line between any kind of cooperation that you might even find in single-celled organisms, or ant colonies, say, versus some genuine morality that makes humans perhaps distinct? Now, here in this paper, I've argued that unlike any other field, the science of morality has drawn attention from an extraordinarily diverse set of disciplines. An interdisciplinary research program has formed in which economists, biologists, neuroscientists, psychologists, and even philosophers have been eager to provide answers to puzzling questions raised by the existence of human morality. Models and simulations, for a variety of reasons, have played various important roles in this endeavor. The use, however, has sometimes been deemed as useless, trivial, and inadequate. The role of models in science of morality has indeed been vastly underappreciated. This omission shall be remedied here, offering a much more positive picture on the contribution modelers made to our understanding of morality. Now, the paper will be structured as follows. First, I'll provide an introduction. Then I go into the methodological question of why we want to model morality, why there's a benefit here to, say, just doing empirical investigations. Thirdly, I'll address the empirical adequacy of such models. Can they ever be supported sufficiently by evidence to make them useful? And finally, we'll address what such models could tell us about the moral status of morality itself. Now, let's dive right in this paper in more detail. Since Robert Axelrod's famous work, The Evolution of Cooperation, economists, biologists, neuroscientists, psychologists, and even philosophers have been eager to provide answers to the puzzling question of why humans are not the selfish creatures natural selection seems to demand. Now, see, for instance, Dawkins' book, The Selfish Gene, where this is often discussed. The list of major contributions is vast. Particular importance here is Brian Skyrm's pioneering use of evolutionary game theory, which I'll abbreviate henceforth as EGT, and the replicator dynamics in his book, The Evolution of the Social Contract and the Stag Hunt and Evolution of Social Structure. Further important book-length contributions on evolutionary morality are offered by Hugh Wilson, Ken Binmore, Franz de Waal, Elliot Sober, and David Sloan Wilson, Richard Joyce, Jason Mackenzie Alexander, Martin A. Novak, and Roger Highfield, Samuel Bowles and Herbert Gintis, Christopher Böhm, and most recently Patricia Churchland. So, The efforts of these and many other authors have led to the formation of an interdisciplinary research program with the explicit aim to explain and understand human morality, taking the first steps towards a genuine science of morality. Let us call this research program the Explaining Morality Program, EMP. You can see philosophers are often fond of using such abbreviations. For a variety of reasons, models such as those provided by Skyrms have played a very important role in this endeavor. The most illustrative reason being the simple fact that behavior does not fossilize. Models and simulations alone, however, have been doubted by many to provide much of an explanation when it comes to human morality. The work of modelers in the EMP, the Explaining Morality Program, has been underappreciated for a number of reasons that can be roughly grouped together in virtue of the following three concerns: the complexity of the phenomenon, the lack of empirical support, and perhaps the most furthest criticism being the supposedly non-reducible normative dimension morality embodies. Makes it different from, say, any other empirical phenomenon. There's something normative going on here. In this paper, I shall argue that this underappreciation is a mistake. So, the interdisciplinarity has played a crucial role in the advancement of our moral understanding. It has led to an underappreciation of the role and contribution, however, that highly abstract and idealized models have played. Many responses to the modeling work within the Explaining Morality Paradigm, EMP, are characterized by eager attempts to draw lines in the sand, that is, determine prescriptive norms that would limit the justified use or misuse of such models. These criticisms range from sophisticated ones, perhaps the most convincing one offered in Levi, to rather naive ones, such as those offered in Arnold, 2008. The latter goes so far as to label such models as useless, trivial, and inadequate. In a harsh review of Arnold, Solomon, 2009, criticized Arnold's arguments against the use of such models, deeming them unconvincing and exceedingly ambitious. Modelers may very well be tempted to attack Arnold as a strawman and conclude that the criticism of models for the evolution of morality can easily be debunked. However, such an approach would ignore the more sophisticated arguments that have been offered. For the purposes of debunking the strongest arguments against such models, any mention of Arnold's criticisms hardly deserves mention here. Now, I've been influenced here by a lot of philosophers who dabble themselves in modeling, Solomon included. Now, Arnold is by no means alone here, however. His attitude is one that is extremely widely shared. His mistakes illustrate a shared pattern that can be found, though in a much weaker form, across the literature. It is a sort of a priori skepticism and perhaps dislike among philosophers and more experimentally oriented scientists about the role of models in science. This skepticism is one I hope to at least partially dispose of here. I shall demonstrate that models for evolution of morality are neither too simplistic, nor do they lack empirical data. To provide us with genuine explanatory insights. Recent advances in the philosophical literature on models, especially on model pluralism and the role of multiple models, now I've written a paper on this as well, we'll go into this in a different episode, should allow us to recognize that not only such often exaggerated limitations, but also the strengths of models in the EMP. Again, EMP explaining morality paradigm for those perhaps that are listening to this episode only without having any use of, say, video. I think Spotify as well as YouTube offer to not only listen to this podcast, but also watch it. But anyhow, EMP, henceforth, explaining morality paradigm program. the latter of which have often been underappreciated, while the former have been overstated. And this omission shall be remedied here. So the goal really is to highlight the strengths of models. They don't just have weaknesses. All right. In order to demonstrate a number of conceptual mistakes made in the literature, I shall largely draw on Jason Mackenzie Alexander's book, The Structural Evolution of Morality. Now, fun anecdote here, perhaps. For a while, I was thinking of going to pursue a PhD at the LSE. I even had an offer, but Sydney was in the end too compelling, perhaps. Now, Jason Mackenzie Alexander nevertheless offers perhaps the most extensive modeling treatment on the evolution of morality. I was very interested in the evolution of morality during my undergrad as well as master. That has somewhat weakened in recent years. I think the field is perhaps a bit oversaturated now with work, but back then I thought I could add something useful, especially in virtue of looking at how we can combine evidence from different fields, such as modeling, empirical research from different fields, philosophy, in order to understand morality better. And this naturalistic work I'm still very much interested in. And we'll see if I'll, at some point, decide perhaps to go back into this. Now, building on previous work by his former supervisor, Brian Skyrms, Alexander analyzes a large scope of exceedingly complex and arguably more realistic models in order to illuminate the requirements and potential threats to the emergence and spread of moral behavior. He concludes that morality can be explained by a combination of evolutionary game theory, abbreviated as EGT, together with a theory of bounded rationality and research in psychology. In doing so, he attempts to answer two distinct questions. One, how could something as altruistic as human morality emerge? And two, how did it persist against the threat of cheaters? For the purposes of this paper, Alexander's book serves as a highly attractive case study for two reasons. Firstly, Alexander's contribution relies solely on highly abstract and idealized models of precisely the form often criticized as too simplistic to provide us with genuine insights for phenomena as complex as human morality. Secondly, while economists, psychologists, biologists, neuroscientists, and even political scientists have provided substantial contributions to the EMP, philosophers have offered distinct and extremely valuable insights by drawing conceptual distinctions. As both a modeler and philosopher, Alexander treads very carefully, only suggesting possible insights his book may provide. Most, perhaps, of the famous books here, I don't want to mention any names if you read them, are often much more ambitious, stating their conclusions in a much stronger form. Alexander, to his credit, is very careful. In fact, as I say it here, at times he even underestimates his own scientific contribution, arguing that it does not tell us much, if anything, without the supplementation of much more empirical data. One may regard such humility as a virtue, but at times even an unbiased reader may get the impression that Alexander himself sees his contribution as superfluous. However, all of this humility seems to be thrown overboard in the very end of his book, where he discusses and suggests implications of the EMP for an understanding of morality itself, vindicating the objective status of morality. Now, that seems, in fact, to be quite bold. But of course, philosophers are interested in not only morality as an empirical phenomenon, a cultural phenomenon to be investigated, but also from a normative perspective. Yeah. Now, nevertheless, despite giving in too much to the criticisms of this explanatory program, Alexander avoids several pitfalls that might obscure our understanding of the epistemic contribution such models can provide. Here shall shed a much more positive light on the role of models in the EMP, or as it is sometimes referred to, the study of moral dynamics. See Exelman 2009. Now, the structure of this paper corresponds roughly to the three concerns raised against the role of models in the MP illustrated above. Firstly, in section 2, I discuss Alexander's contribution and explore the most important question within the literature, that is, why model morality? What's the benefit here? In section 3, I respond to concerns regarding the empirical adequacy, before finally, in section 4, I cast doubt on the possibility of vindicating the objective status of moral norms via the EMP and conclude the discussion. So, why model morality? Evolutionary explanations of morality have been of scientific interest since at least Darwin. Proto-Darwinian explanations, however, have been around for a long time. As Hexelman 2009 points out, DMP has a long scientific tradition going back as far as ancient Greece. Protagoras, in one of Plato's dialogues, provides perhaps the first scientific explanation of morality as a set of norms and enforcement agencies being an invention of humanity to escape a Hobbesian state of nature. Couched in terms of a myth, we may treat this as a mere just-so story. Much later, David Hume came astonishingly close to providing a Darwinian explanation of morality himself. Hexelman and Will, 2013, determined 4 key components to Hume's proto-Darwinian account: a pre-societal human nature with confined generosity, the invention of artificial values to be reinforced and internalized through approval and disapproval of others, the vision of labor, reaping the benefits of cooperation and trust, and the invention of central authorities that monitor, enforce, and eventually punish behavior. Already much more sophisticated, but still similar to the myth of Prometheus and Epimetheus told by Protagoras. These accounts are mere story and myth in the case of Protagoras, and in the case of Hume, an informal suggestion of how possibly explanation leave much to be desired. But they were, nevertheless, the best explanation available at the time. Luckily, it didn't take 2 millennia for the next advancement. Richard Joyce, in his book The Evolution of Morality, argues that less than a century after Hume's death, Darwin delivered the means for pushing the inquiry into human morality further, filling out a gap Hume could only describe as nature. Charles Darwin, of course, himself suggested that the origin of morality can be explained with his theory. And now I quote here Darwin: "It may well be first to premise that I do not wish to maintain that any strictly social animal, if its intellectual faculties were to become as active and as highly developed as in man, would acquire exactly the moral sense as ours. In the same manner as various animals have some sense of beauty, though they admire widely different objects, so they might have a sense of right and wrong, though led by it to follow wildly different lines of conduct. If, for instance, we take an extreme case, men were reared under the precisely same conditions as hive bees, there can hardly be a doubt that our unmarried females would, like the worker bees, think it a sacred duty to kill their brothers, and mothers would strive to kill their fertile daughters, and no one would think of interfering. Nevertheless, the bee or any other social animal would gain in our supposed case, as it appears to me, some feeling of right or wrong or conscience." 1879, page 67. Now, this, of course, is still just a how possibly explanation, or as critics like to call them, a just-so story. It should be clear that from Pythagoras over Hume to Darwin, significant improvements in explanation of morality have been made, with more and more gaps being closed. Explanations come in degrees, and this research program is providing better and better explanations, and perhaps the best for the moment. So rather than thinking as explanations as something that is fully explained, no gaps left, only then have we offered the real explanations, we should instead think of things being more or less explained. The less mysterious than they have been before. And that, of course, allows for explanations perhaps opening some more mysteries. Unfortunately, it took a while until informal evolutionary explanations resting on the good of the species were replaced with formal evolutionary game theory models showing that the origin of moral behavior is not much of a mystery after all. Skyrm's 1996 was the first to apply evolutionary game theory to unpack Hume's account in a formal manner, with others following in the creation of new models and simulations. These sets of models strengthen our confidence that morality could have evolved in a way envisioned by Hume and Darwin, providing considerable explanatory power, even though empirical work has hitherto been largely left out of the picture. Even the work of moral philosophers in this Humean research program has been very empirical and guided by science, trying to unpack the idea of morality being a mere artifact. See Mackey and Joyce. Being a case in point for the division of labor between philosophers, modelers, and empirical researchers, modelers such as Skyrm simply continue an old philosophical school of thought with the modern tools of science, a move that ought to be encouraged. Before engaging in a more detailed analysis for our case study, that is the models Alexander 2007 provides, I shall take on his last chapter, titled Philosophical Reflections, where he explores the philosophical implications of his models. Though the appearance of moral behavior in Alexander's models is rather robust and remains stable even in the face of the factors, more, he argues, needs to be said in order to draw inferences about human morality. Quoting Philip Kitcher, Alexander 2007 highlights a general problem for evolutionary explanations of morality. It's important to demonstrate that the forms of behavior that accord for our sense of justice and morality can originate and be maintained under natural selection. Yet, we should also be aware that the demonstration doesn't necessarily account for the superstructure of concept and principles in terms of which we appraise those forms of behavior. Kitcher, 1999. In response, Alexander introduces a distinction between thinly and thickly conforming to morality. Though an individual's action may conform thinly with morality, that is, for instance, fair sharing, the individual may fail to hold sufficient, quote, to hold sufficiently many of the beliefs, intentions, preferences, and desires to warrant the application of the term moral to his or her action. Alexander 2007, page 268. In contrast, thickly conforming to morality satisfies sufficiently many of these conditions. If someone acts morally out of purely selfish reasons, we may not want to call such behavior moral. E.g., someone giving to the poor in order to improve their reputation. Akin to Kant, it is the distinction between behavior in compliance with morality or acting out of the right, that is, moral reasons. When evolutionary game theory models are used to simulate the emergence and persistence of moral behavior, we only observe the quote, frequencies and distribution of strategies and perhaps other relevant properties. Alexander, 2007, page 270. What is lacking here is the role of psychology, perhaps even neuroscience, in the production of such behavior. Even if we allow for very complex strategies, such as those submitted to Axelrod's 1984 computer tournament, they still allow for purely behavioral interpretation. This problem lies at the core of attempts to model the evolution of morality. Critics argue that a complete explanation for the evolution of morality requires an understanding of the internal psychological mechanisms that produce such moral behavior. Alexander concedes to this criticism, suggesting to enrich these models with, quote, non-strategic psychological elements, page 273. He grants that evolutionary game theory alone is not sufficient for an evolutionary explanation of morality, but that together, quote, with experimental psychology and in recent work in the theory of bounded rationality, some of the structure and content of moral theories can be explained by working in tandem, page 274. This position, of course, is a much weaker one than to claim that evolutionary game theory alone could provide genuine insights into the origin of morality. But even if, as I suggest, Evolutionary game theory might be sufficient to explain much of our moral behavior. Alexander aims at more. First of all, as Kitcher suggests, evolutionary game theory enables the important identification of behavior that maximizes long-run expected utility or fitness. A second step then is required to explain the motivational structures, which are, quote, actually producing this behavior in boundedly rational individuals. 2007, page 275. Here, Alexander identifies two mechanisms. First, the moral sentiments bringing about motivation to act, and secondly, moral theories instructing us, quote, how to act once we have been motivated to do so, page 275. Therefore, Alexander argues it's precisely because we're boundedly rational that the outcome produced, quote, by acting in accordance with moral theory are such that they tend to maximize our expected utility over the lifetime of the individual. Page 275. Rationality requires us to rely on heuristics. And these, luckily, according to Alexander, are often moral heuristics, such as fair split and cooperation. And analyzing the influence of moral heuristics on our thinking, Alexander, based on a distinction by Giuseppe et al. 2001, discusses three separate roles that moral heuristics play in our thinking. Firstly, moral heuristics limit our set of options, e.g., not even considering to poison the dog of our neighbor, even though his barking may disturb one's sleep. Secondly, moral heuristics guide our information search. That is what we need to consider before making a judgment. Thirdly, but closely related to the second point, moral heuristics, quote, tell us when to terminate an information search. Page 277. When we find out that someone killed a human infant for fun, it is sufficient for a moral judgment regardless of any additional information. Daniel Dennett, 1996, has defended a similar position on moral judgments, calling them conversation stoppers for otherwise costly debates. Relatedly, Alexander makes the rather contentious claim that though we use moral reasoning, moral theories have their form precisely because they track, quote, long-run expected utility, page 278. The key to the evolution of morality, he argues, quote, lies in the fact that we all face repeated interpersonal decision problems of many types in socially structured environments, page 278. Hence, the structural evolution of morality. As, quote, the science of morality is only in its infancy, page 281, there must remain some unanswered questions in our current explanations. However, and I agree here with Alexander, this, quote, is no reason why we should not make the attempt. Page 282. Akin to primates, evolution equipped us with, quote, emotions and other cognitive machinery, page 284, in order to solve interdependent decision problems, such as those arising in the prisoner's dilemma, the stag hunt, and the divide cake game. Rosenberg makes a similar argument and extends it to love as the solution, quote, to a strategic interaction problem. 2011, page 3. Analogously, the mere fact that love is an evolved response does not have to undermine our conviction that the feelings and intentions associated with it are not genuine or worthy of pursuit. The same may hold for morality. Now, Alex Rosenberg, who is cited here, will in fact be our next guest on this podcast. Emotions and our cognitive machinery is the raw material evolution had to use in order to solve more complex problems humans were increasingly facing, e.g., trust and introduction of property rights. With the evolution of language, this arms race in human evolution could only gain speed. We do not yet know which of our moral attitudes are hardwired and which are culturally acquired, but there's obviously no reason not to ask the question. As we shall see, many of the EGT models used by Alexander, Skyrms, and others allow for both a cultural and biological interpretation. As cultural evolution operates at a much higher speed, however, many modelers such as Alexander give them a cultural operation. And that is because if it operates at a faster speed, it's more likely to operate quicker. The force, you might say, of cultural selection will be stronger than mere genetic selection. which doesn't mean that cultural selection couldn't also force some genetic adaptations, perhaps, say, genes for um, more fairness, more kindness, less aggression, and the like. Just a more cooperative, say, psychological disposition that makes them better able to learn those cultural norms. Now, establishing the motivation for his models, Alexander henceforth turns to the evidential support for evolutionary explanations of morality in order to turn them into more than just so stories. That is, evolutionary explanations without empirical evidence. Evolutionary explanations are often faced with the criticism of providing nothing more than just so stories, that is, historical accounts without any empirical evidence in their favor. For Charles Darwin, it was very important to collect plentiful evidence for his theory of natural selection, and biologists to this day continue to accumulate corroborating evidence. However, when biologists try to explain the occurrence of a certain behavior or phenotype in general, they often start by hypothesizing how the trait could be adaptive. This research program is often criticized as a sort of Panglossian adaptationism. That is assuming the adaptiveness of a trait without further evidence. Though Alexander only considers 2 experiments, they are highly suggestive that our conception of fairness is somewhat flexible and strongly correlates with the outcomes our own group receives. Though a philosophical review of the vast literature on moral experiments should be undertaken, it is beyond the scope and purpose of this paper, which merely is concerned with attempts to model morality. Nevertheless, an interesting task, which I was once envisioning, perhaps for my PhD project. So as a side note, it is a rapidly growing field. And I wonder even if they're still used to this, because the field is now so large, it might be hard even in a whole book to summarize it all. Nevertheless, that doesn't mean that no one could attempt this task. It is, after all, a very interesting phenomenon. And some of the best work here often doesn't come from philosophers, but rather psychologists. But as so often, it is an interdisciplinary work that will probably make the most progress here. Nevertheless, the just so story critique has evolved into a term of abuse, used against all kinds of model-based explanations. And that's what I'm opposed to here. In this paper, I shall attempt to argue against this commonplace treatment and highlight the wealth and diversity models can provide in the explaining morality paradigm. Though brought up as a game theorist, Alexander recognizes the weaknesses in the assumptions of standard rational choice theory. In order to avoid charges of unrealisticness, Alexander's models for the evolution of moral behavior make no strong rationality assumptions. Rather, he uses models of bounded rationality combined with evolutionary game theory to account for the evolution of morality. Sugden anticipated as much in a paper on the evolutionary turn in game theory, stating that, quote, the theory of human behavior that underlies the evolutionary approach is fundamentally different from what is used in classical game theory. 2001, page 127, with far less contestable rationality assumptions, though similarly in their mathematical formulation. In short, Alexander treats bounded rationality theory as descriptively superior to standard rational choice theory. However, with the threat of only providing so-called just so stories, evolutionary explanations in general are often dismissed by pointing to the multiplicity of evolutionary accounts we could give for the appearance of a phenomenon. I also want to note that you can download this paper, of course, to read along at your own speed. Forgot to mention at the beginning, I've mentioned it with some of my previous paper reads with comments. Back to the paper. These objections, however, miss the mark when they are supposed to show that evolution plays no part in explaining morality. Alexander's former supervisor, Brian Skirms, himself working on evolution of social norms, makes this criticism of just so stories charges explicit. Why have norms of fairness not been eliminated by the process of evolution? How then could norms of fairness of the kind observed in the Ultimatum game evolved? That's a quote from his 1996 book, page 28. In this section, I argue that such a criticism is highlighting something important that Robert Sugden tries to capture in his work on model-based explanations. Though very similar arguments have been made by Geer, Godfrey Smith, Weisberg, and Levi. Sugden's work serves as an elegant illustration of Alexander's aims for at least two reasons. One, Sugden's account is partially motivated by evolutionary game theory models used in both economics and biology, and two, his credible world terminology maps neatly onto justifications, goals, and inferences Alexander is drawing himself. Models, Sugden argues, are parallel worlds, artificially created, which can be used to draw inductive inferences to the real world. At least, he argues, such as the practice in economics and biology. In both of these fields, phenomena are complex and can be multiply realized by different mechanisms. This is why Sugden argues we need induction to bridge the gap between the model world and the real world, even though he grants that this may seem unappealing to some philosophers. A model here, in virtue of its idealizations, is a sort of fictional entity that enables us to draw inductive inferences about the real world via similarity relations to the model world. Hence, Sugden argues modelers aim to create credible worlds that we could imagine being real. It is not truth per se that is aimed for, but rather a sort of credibility that is deemed able to tell us something about the real world we live in. To do so, modelers are required to provide us with relevant similarities between what is happening in the model and what could be going on in the real world, perhaps requiring a sort of elaborative story or narrative linking the two. In the following, I argue that Alexander's contribution to the EMP consists in the construction of such credible worlds, from which we can draw inductive or abductive inferences to the real world. Analyzing the phenomena, cooperation, trust, fairness, and retribution, Alexander 2007 conducts his project by exploring different and increasingly complex models in which he wants to explore the evolution of morality. He goes on to employ 5 models, that is the replicator dynamics, lattice models, small world networks, boundary degree networks, and dynamic networks, each introducing more and more elaborate forms of population structure back into the picture and increasing the realism of his models. He analyzes 4 different dimensions of morality, that is cooperation, trust, fairness, and retribution, among to a set of 20 models, each having their robustness tested in several iterations. Each of these models alone seems to tell us very little about the real world. Taken together, however, this extensive set of robust models supports Alexander's assertion that population structure plays a very important role in the evolution of morality. First, he starts with a simple model used in evolutionary game theory and increasingly the social sciences, that is, the replicator dynamics. As already alluded to, evolutionary game theory allows for both biological and cultural interpretations, explaining the interdisciplinary interest in evolutionary game theory. While the biological form of these models treats replication as biological inheritance, replication has to be interpreted as some form of learning or imitation in a cultural setting. Replicator dynamics are an attempt to model the relative changes of strategies in a population. Again, these can be either instantiated biologically or culturally. Strategies with higher fitness than the population average prosper and increase their share in the population, while those with lower fitness are driven to extinction. Fitness in the biological setting are thus an attempt to model the dynamics of reproduction and natural selection. The following is the continuous replicator dynamics equation. Little point perhaps going into this for those well, not too familiar. Should I go into depth here? I wonder. Oops. Oh, please tell me in the comments, perhaps, if you would want me to read this out in more detail. I think it is perhaps worth simplifying this for those who don't have a math background. Hmm. So I suppose I'll just quickly summarize it. Now, in each round, individual strategies, each strategy increases their share with a population linear to their success, where U stands for the fitness of this strategy encountering a different strategy. And here, just as the evolutionary stable strategy, ESS, familiar from our early evolutionary game theory models, replicator dynamics assume infinite population size, or at least infinite divisibility and random interaction. And these idealizations allow us to analyze the frequency-dependent success of different strategies, whether they are biologically or culturally transmitted. Though he intends his project to model the cultural evolution of morality, grants the replicator dynamics leave it open whether the strategies are genetically or culturally transmitted. So let us consider Alexander's first example and the most analyzed game in game theory, the prisoner's dilemma. We have here a nice matrix where two prisoners can choose whether to cooperate and defect. And the problem is that defecting always benefits. It's always higher than yourself cooperating compared to, I'll say, if the other person cooperates, you're better off defecting. And if the other person defects, you're also better off defecting once again. The problem, of course, here is that if both persons cooperated, they both get a higher payoff than if both defected. So there's only one Nash equilibrium here, defect. The famous game can be traced back to Hobbes, who argued that a powerful leader is required to escape the state of nature, that is collective defection. In fact, his name is mentioned over 20 times in Alexander's book, pointing to the long tradition of evolutionary, explaining morality program. Yeah, so probably not worth going into this here in detail. But if you try to simulate the prisoner's dilemma, what you'll quickly see is that with replicator dynamics, we can see that cooperators are quickly driven to extinction, with the factors taking over the population. And then we can, of course, think about how we might tweak this scenario so a different outcome might arise. As his book is called The Structure of Evolution of Morality, Alexander is aware that human societies are more complex and that we need to account for the social structure of society in order to make these models more credible. In fact, when population structure is introduced, interactions are no longer entirely random, making it possible for cooperators to group together, cooperation can persist and evolve. Therefore, he moves on to explore agent-based models that are lattice models, small world networks, bounded degree networks, and dynamic networks where agents can choose with whom to interact. Increasing the complexity in these models serves then two purposes. On the one hand, the goal is one, to ensure robustness, that is the stability of the outcomes in the model under changes in the model, and on the other hand, two, to increase the credibility of the model. There's a likeliness of it telling us the true story about evolution of morality. As Sugden says, quote, what we need in addition is some confidence that the production model is likely to the job for which it has been designed, that is likely to explain real-world phenomena. 2000, page 11. And this is Alexander's stronger claim, the provision of a how actual explanation. Let me therefore now tackle these two purposes in succession. To explain this and how actual explanation is an explanation that actually captures the actual factors that explain its occurrence, and how possibly explanation captures the one of the perhaps many ways a phenomenon might have happened. Looking at robustness first, Alexander claims that the results in his models are sufficiently robust to suggest that moral behavior can emerge and remain stable in a population of boundedly rational agents. I agree with Kurowski and Litinen that robustness analysis is somewhat implicit in Sugden's account of inductive inference. This, however, should be interpreted as a continuous inference from increasingly similar model worlds to the real-world counterpart. Robustness analysis and inductive inference are closely related and overlap in important respects, but Sugden is justified in making a distinction on grounds of their different epistemic properties. Robustness analysis increases internal validity for the model world, while this internal validity is a prerequisite for establishing external validity in the real world. When slightly changed alteration of the model are seen as the target themselves, this distinction, however, breaks down. I take Levi's subtle criticism of the modeling literature on the evolution of morality to target a tendency of not sufficiently distinguishing between these two ways in which validity can be increased. Modelers such as Skirms, Levy argues, take the models to establish external validity when really only internal validity has been vindicated. I will say more about Levi's criticism in the next section on the empirical adequacy of these models. Yeah, so here I have actually a nice footnote that I don't usually read out, but it helps perhaps to understand one of the core notions here. Nash equilibrium is introduced by John Nash, is the central, in fact, most important solution concept in game theory. The concept picks out a combination of strategies, that is, one for each player in the game, in which none of the players has an incentive to unilaterally deviate from his chosen strategy, while the strategies others have chosen remain fixed. In the prisoner's dilemma, this classically leads to only one unique solution, that is mutual defection. Morality quickly suggests itself as an evolved social institution to such inefficient equilibria. Now, when models are used to learn about human morality, Sugden, Cartwright, and others are correct in arguing that the purpose of models is to learn something about a real-world target system. Francesco Guala argues that it is, quote, necessary to investigate empirically which factors among those that may be causally relevant for the result are likely to be instantiated in the real world, but are absent from the experiment, or vice versa. Quote end, 2005, page 157. This procedure of establishing external validity not only applies to inductive inference from the artificial experimental world to the real world, but also to inductive inference from the artificial model world to the real world. In both cases, we want to draw inferences from highly idealized and abstract mechanisms to a causal mechanism operating in the real world. As several authors have recently pointed out, there are more important similarities than relevant differences between models and experiments, which makes it difficult to justify drawing any hard boundaries between the two. In order to gain confidence that Alexander's story provides us with the actual explanation of human morality requires more, especially evidence from psychology and neuroscience, in order to learn about the causal mechanisms behind moral behavior. Even though our morals are robust, this robustness in itself only tells us something about the evolution of moral behavior in the model. That is, unless relevant similarities obtain between the real world and the model world. Sugden argues that a transition, quote, has to be made from a particular hypothesis, which has been shown to be true in the model world, to a general hypothesis, which we can expect to be true in the real world too. 2000, page 19. That is inductive inference. Sugden explicates three such inductive schemata: explanation, prediction, and abduction. For the purposes of this paper, only his explanation schema is relevant. And I quote him here. E1 in the model world, R is caused by F. E2, F operates in the real world. E3, R occurs in the real world. Therefore, there is a reason to believe E4 in the real world, R is caused by F. 2000, page 12. The phenomena are in question is the emergence and stability of moral behavior. So you can see that better. Though Alexander explicitly wants to explain more, that is the emergence and stability of morality, we shall first consider whether these models can explain moral behavior. What we need to establish in order to make justified inductive inferences, that is extrapolation from the model world to the real world, as relevant similarities obtain. That is what we have to figure out here. While the relevant set of causal factors in the model, that is cultural evolution, do operate in the real world, of course, this may be an unavoidable feature of generalized theories. When Sugden speaks of a model's credibility, he's not talking about a literal truth, the truth likeness, a description of, quote, how the world could be, page 24. A credible counterfactual world. For a model world to achieve this kind of credibility, it needs to cohere with the causal processes we know to be operating in the real world. The agents postulated in our model need to be in a relevant sense, like real agents in our world. By using evolutionary game theory and bounded rationality models, Alexander intends to trump the standard rational choice theory models in virtue of credibility. Drawing inferences from his models, therefore, he argues, is at least inductively more justified than standard game theory explanations for the evolution of morality. This concession, however, is unlikely to convince many critics of rational choice theory. However, if standard rational choice theory models are justified, his models should be justified by extension in virtue of their enhanced credibility. If the standards models fail to achieve credibility or rather external validity, we need some further argument to see how Alexander's models are explanatory. When Alexander moves from the simple replicator dynamics to lattice models, he is continuing his quest for a more credible model world. Here we drop the unrealistic assumption of random interaction in an infinitely sized population for a one-dimensional lattice in which everyone has two neighbors to interact with. Secondly, Alexander analyzes how different learning rules change the strategy dynamics in his models, all of which are rather simple but perhaps better capture the actual strategy changes in human agents. As the assumption of only interacting with two neighbors is highly unrealistic in itself, Alexander moves to small world networks where some agents have an additional interaction possibility by being connected over a bridge, further increasing credibility. Alexander moves to bounded degree networks where every agent has a certain number of connections between different agents, and they can vary. Here, connections need to not be neighbors and are randomly assigned, creating networks that look fairly similar to interaction networks in the real world. However, humans obviously do not choose with whom to interact entirely at random. When we encounter someone who cheats in a cooperative endeavor, we will try to avoid them interact with someone else next time. Alexander draws on Skirm's and Permantel's 2000 model of social network formation in order to model changing interaction frequencies. Without going into the specifics and intricacies of each of these models to illustrate an important point, Alexander's book follows the modeling strategy of first ensuring robustness and internal validity before moving on to more credible model worlds that gain complexity and inferential power. The latter approach must, of course, be closely related to empirical research into morality, most importantly, perhaps moral psychology. Robert Sugden's account of modeling is justified in virtue of being a naturalistic, pragmatic account of the actual scientific modeling practice. Models are successfully explained in explaining, but do so by induction. Therefore, we should accept induction as a valid principle in a modeler's toolkit, quote, however problematic that may be for professional logicians. 2009, page 19. So Sugden is digging a bit perhaps into what might be considered offensive by some who hold a view like that he's criticizing here. So in a research paper on evolutionary game theory, Sugden writes, quote, evolutionary game theory is still in its infancy. A generally evolutionary approach to economic explanation has an enormous benefit amount to offer. Biology really is a much better role model for economics than is physics. I just hope that economists will come to see the need to emulate the empirical research methods of biology and do not just its mathematical techniques. 2001, page 128. Alexander doesn't fall into this trap, for he only sees his mathematical models as a subset of the necessary steps towards a general explanation for the evolution of morality. This is where empirical evidence needs to be accumulated and studies conducted, analyzing development psychology with respect to social norms. Alexander's work, however, guides the way for such empirical research and theory testing to commence in a field that is still nebulous and wide. How to move from robust evolutionary game theory models to the real world will be explored in the next section. 3. Empirical adequacy. And now, let me check. Yeah, I think we can finish this in these sessions without me having to do another recording. Although, I think we can try at least. All right. So instead of splitting this into 2 episodes, I'll finish this in one: free empirical adequacy. The most sophisticated criticism of attempts to model the evolution of morality has recently been offered by Arnon Levi, 2011. Rather than denying the importance of models, Levi argues that there are 2 distinct modes of inquiry, in which indirect modeling can be used to study otherwise complex phenomena. Levi argues that the work of Skyrms, Alexander, and others is characterized by internal progress achieved within the model rather than target-oriented progress, where we learn more directly about the target system itself. While Levi does not go as far as to argue that the strategy is a pure conceptual exploration, he suggests that it is, quote, more conceptual in spirit, aimed at understanding the initial model itself, 2011, page 186. Target-oriented modeling, Levi argues, progresses by incrementally adding causal information primarily guided by considerations of empirical adequacy. In contrast, models for evolution of morality explore the, quote, subtleties of a constructed setup, quote, end, page 186, with empirical adequacy only playing a minor role. Similarly, Sugden suggests that, quote, a model cannot prove useful unless someone uses it, and whoever that person is, he or she will have to bridge the gap between model world and real world. 2009, page 26. Though Alexander downplays the role of his models by saying that they alone cannot account for much, he suggests that jointly with theories of bounded rationality and research on psychology and economics, we can get closer to the actual explanation of how morality evolved. This is the main motivation behind Sugden's credible world account of modeling. This is what he wants: a connection between the model world and the real world. If models were only about the conceptual exploration and providing theorems, any mention of the real world and the relationship of the model to it would be nothing but telling a story to sell one's model. Levi, 2011, suggests that this is what might be happening in the models provided by Skyrms and Alexander. However, as I shall argue here, the modeling strategy of the evolution of moral norms explicitly acknowledges relevant real-world factors and successively tries to increase the credibility of his models. In the following, I shall argue that evolutionary game theory models can inform empirical research and vice versa. Rosenberg and Lindquist, again, Rosenberg will be guest soon on this podcast, wrote a paper on evolutionary game theory models for cooperation and how to test them empirically, which will prove highly useful for the section. They argue that we can use archaeology, anthropology, primatology, and even gene sequencing to support EGT models. Supporting Alexander, they argue that human cooperation is too sophisticated, conditionalized, and domain general for it to be a genetically hardwired trait. What Alexander does not consider is potential for gene culture co-evolutionary. But I take him to make a deliberately weak claim that even if it turns out that human morality is entirely cultural, his models will still be useful. If we find empirical evidence for hardwired behavior, then all the better for an evolutionary explanation of morality. However, in order to have a credible evolutionary game theory model, Rosenberg and Lindquist argue, already requires a lot of substantial assumptions, for example, emotion, reliable memories, a theory of other minds, language, imitation learning, and the like. Experiments in economics and psychology, often done in the form of games, can inform us about how humans act and how a change in conditions changes human behavior. Such empirical work can then help the modeler to not only increase the credibility of his models, but also to eliminate those models would tell a completely misguided story of the evolution of human morality. Rosenberg and Lindquist provide the popular example of the big game hypothesis, big game hunt hypothesis, as an explanation for why humans started cooperating. They point out that the empirical data suggests that big game hunter was an inferior strategy in comparison to gathering, not even granting the payoff specified in a stag hunt game. Though the big game hunt hypothesis tells a nice story of why humans started to cooperate, we should treat it as even less than just so story because the evidence suggests it is most likely false. As an alternative, they propose cooperative child caring, which interestingly also fits the mathematical description of a stag hunt game. In light of empirical evidence, they argue that modelers should try to alter their stack-hunt models for trust by thinking about the potential payoffs of cooperative childcare rather than the payoffs of cooperative hunting. Such is the nature of this enterprise. Both modeling and empirical research can inform each other in a variety of ways. Though many models will be discarded, this leaves us with a much narrower set of how possible explanations and gets us closer to the actual one. They close their paper by stating that it's not, quote, for philosophers to speculate how this research once commenced will eventuate, page 156. But it is nevertheless necessary to bring in line the theoretical work done in evolutionary game theory with the empirical data from various fields. Otherwise, evolutionary game theory models are nothing but conceptual exploration, and as Sutton points out, modelers should and can aim for more. Nevertheless, Hexelman 2009 suggests caution against the hope that the, quote, huge gap between macroscopic models of moral dynamics and the known variety of microscopic processes that seems to generate certain assumed overall effects, page 5689, can be breached in the near future, if at all. Criticisms directed against Alexander, stating that he failed to provide a complete explanations, is not nearly as effective when a complete explanation is not reachable anyway. While we might consider Alexander's work as only one of the first steps in getting closer to complete explanation of human morality, it remains an important step nonetheless. Though the empirical data is weak, or rather because of it, it is so important to combine the research results from different fields. Models, far from being a mere add-on to this research program, appear to be a necessary and integral part of the of the explaining morality paradigm, transporting it more and more into a science in its own right. Let me now conclude this discussion with the controversial debate whether such models have any impact on the moral status of morality. Implications for the moral status of morality, section 4. Alexander concludes that evolutionary game theory, coupled with the theory of bounded rationality in recent experimental work, bridging the gap between psychology and economics, provides what appears to be a radical restructuring of the foundations of moral theory. That's a quote, showing that the content of, quote again, moral theories are real and binding. 2007, page 291. Though their content is highly dependent on us and the structure of society. Alexander 2007, rather than providing an evolutionary debunking argument for morality, claims to provide an objective but relative basis for morality insofar as he shows that the principles of morality are in the best long-term interest of everyone, a claim that may be seeming to be just as radical, of course. This distinction is important as it is often treated anonymously. However, as I shall argue, Alexander goes one step too far when he treats the instrumental justification of morality as an epistemic justification. Due to the importance of population structure, illustrated in this book, Alexander argues morality is necessarily relative to the structure of society. Morality, he argues, is objective but relative. This is an ambitious suggestion, standing in stark contrast to the careful conclusions Alexander has drawn in the rest of his book, and hence deserves closer inspection. Unlike Joyce, Street, and Rosenberg, who provide evolutionary debunking arguments for the objectivity of morality, Alexander argues that his models, rather than undermining, are able to vindicate morality. And in doing so, he draws explicitly on Hume. Quote, much work has been done to taken in order to unpack Hume's certain proposition that, quoting Hume here, this is only from the selfishness and confined generosity of men, along with the scanty provision of nature has made for his wants, that justice derives its origin. As for the origin of justice, so for the rest of morality. Page 291. For Humeans, in the tradition of Bernard Williams and arguably Hume himself, notions of objectivity were always somewhat odd. In fact, all of the three evolutionary debunkers mentioned above see themselves as Humeans. They argue that in light of an evolutionary explanation for the adaptiveness of moral attitudes and behavior, there's neither a need nor should we endorse any magical property that makes morality somehow objective. And I'll talk about this with one of them, Alexander Rosenberg, in detail in the next episode. Nevertheless, Richard Joyce, in his book The Myth of Morality, explores the possibility of indicating the objectivity of morality by linking it to rationality, as perhaps the strongest candidate view to avoid the conclusions of the error theorist. See Mackey. An error theorist typically thinks that all moral statements are false because they don't track any truth, they don't track any real phenomenon. Alexander's argument for the vindication of morality rests on the same motivation. If it can be shown that it is in everyone's interest to act according to morality, morality can be saved. For this approach to be successful, Joyce argues we would need to arrive at some sort of categorical imperative that derives from rationality alone. That is precisely the route Kant took to save the status of morality from Hume's philosophy. For Humeans who see reasons as relative to desires, aims, and preference, perhaps also beliefs, this approach must be futile. The moral heuristics will not only be relative to the structure of the society we live in, but also relative to the aims and desires we have, and hence subjective. They would be nothing more than mere heuristics that apply to the majority of the population and majority of circumstances. Alexander does not see this as a problem. In fact, he sees it as sufficient for grounding morality as something objective, but nevertheless relative. He doesn't think something like this was in the offing to begin with, something that would apply exceptionless to everyone. However, as I see it, the previously provided arguments are sufficient for casting doubt, in fact, on the project of vindicating the objectivity of morality by pointing to a highly relativistic notion of rationality, crucially depending on the social structure of society. For even if we grant that this is a sort of objectivity, it is not what humans typically refer to when talking about the objectivity of morality, nor is it what meta-ethicists are usually interested in. Error theorists like Mackey, Joyce, and Rosenberg readily accept the debunking. Alexander, however, prefers a more subtle version of what we might mean by moral objectivity. His work captures something important. The advice we give our children, the moral norms we teach, are likely to be in their long-term best interest. They are useful heuristics that evolve to reap the benefits of cooperation and strategic interaction problems, and as Alexander points out, they're highly contingent on the social structure of society. Levi suggests that the models explored in the evolution, explaining morality paradigm (EMP) could provide us with insights into the desirability of certain institutions and social norms, merely in virtue of their stability. For meta-ethics, however, the impact of the EMP may be severe. Akin to an electromagnetic pulse, EMP, now, I see I did a pun here in this paper. You might find this enjoyable. The explaining morality program could paralyze much of the traditional work of philosophers working on morality. Hence, it comes with no surprise that many naturalists and philosophers of science seem to hold a deflated sense of moral objectivity, or become error theorists, such as Mackey. Now, we can acknowledge that much more work needs to be done, but the long path to explaining morality is at least partly illuminated by the work of modelers such as Skyrms, Alexander, and others. Clearly, this can only be the beginning of an explanation, but the first steps have been taken. Replicator dynamics have limits and often need to be supplanted with other models. For instance, non-evolutionary game theory models for inheritance and cognitive mechanisms, to provide satisfying explanations of real-world phenomena. A diverse set of multiple models, among which, as Hexelman argues, bridges can be built, may be the best thing we can hope for. But these, as I have argued, are importantly not without considerable explanatory power. It is just the faulty ideal of a complete explanation that blocks such incremental steps towards a better understanding of complex phenomena such as human morality. Now, this was the paper. I hope you found it interesting. Yeah, met lots of people to thank. Read versions of this paper. I thanked them. I gave this paper at a variety of conferences when I was an undergrad and a master student. It's of course very exciting to get to travel to places. I was in Italy, in Rijeka, in Turin, in Italy. That was all very great, I have to say. I got great feedback on this, and yeah, can only encourage if you are a grad student or undergrad, perhaps even having written an interesting paper, to try to submit it to conferences, get to travel, experience what it's like to give talks at conferences, because that was part of why I decided, yeah, philosophical career, why not? This seems like an interesting avenue for research. Um, Anyhow, it is one of my earliest papers, a pre-proofed version, so there will be mistakes in this document. Um, on my website, you can download it. And yeah, I hope you found this interesting. Evolution of morality is certainly an interesting problem that still has to be fully, perhaps satisfactorily explained, even among naturalists who are interested in giving a scientific explanation of morality. There are competing views. Probably they fit more or less together because morality is not just one thing, but a lot of different capacities. Think of fairness, honor, justice, a sense of justice. All these things might have sort of co-evolved with each other. But yeah, I think this brings us to the end of this episode. Now, for any students that have dyslexia or ADHD and for whom reading a paper themselves is hard, I thought it's great to provide an audio version. I hope anyone, though, will find this useful. Perhaps on your way to work, in the gym or the like. I certainly often listen to podcasts, or just AI read versions of papers, uh, different occasions. So yeah, I hope you liked this episode, and I'll see you at the next episode when I'll talk to Alex Rosenberg. Thanks. And bye.